Hi, and welcome to session AIM 319, A Day in the Life of a Data Scientist at JPMorgan Chase. Today, we'll be talking about artificial intelligence and machine learning and how products like Amazon's SageMaker are changing the way that data scientists do their job and expanding the boundaries of what is possible. My name is Tom Lococo. I'm a Principal Technical Account Manager at AWS and a member of the JPMC account team. I spent the last 5 years in the AWS platform helping customers, predominantly in the financial services sector, to implement cloud technologies to serve their customers better. I'm proud to be presenting today alongside Dariush Lakwab, Head of AI/ML Products at JPMC. I'd like to send a shout out to two AWS solution architects, Hannibal Jaju and Ken Jackson, that worked closely alongside Dariush's team in the design and development of the solution that we'll be presenting here today. One of the most exciting parts of my job as a TAM at AWS is helping customers solve complex integration challenges. In the case of AI/ML, implementing SageMaker in a fully secured environment is certainly one of those complex challenges. It's complex because the role of the data scientist is fundamentally about accessing and analyzing many different data sets working with many different people. Those needs sometimes come into conflict with the compliance and regulatory needs to strictly control access to the very same data. From a data governance perspective, we need to be able to track who uses and changes each of those data sets. And from an AI/ML perspective, we need to track the usage and lineage of each of the models that's being applied to the data. Getting this solution approved for deployment at JPMC required us to address each of the requirements shown on the next chart. Firstly, we needed to ingest data from on-premise HDFS file systems where the source datasets reside. Secondly, all data flows needed to be configured as fully private, meaning that they needed to traverse private links with no access to internet gateways or public service endpoints being available. Thirdly, all data in transit and at rest needed to be encrypted to meet the requirements of highly confidential workloads. Fourthly, cloud users at JPMC, including data scientists, typically provision and manage services through a service catalog interface, meaning that they have reduced visibility to the configuration and operation of the underlying cloud services. And finally, requirements for centralized monitoring and logging affect the way that we can debug and troubleshoot AI/ML workloads. We intend by the end of today's session to show you how to implement SageMaker in a fully compliant and secure way using the type of wrappers and controls that JPMC had to implement. So without further ado, let me turn the microphone over to Dariush so that he can tell you about the JPMC OmniAI Platform and how it addresses each of the requirements we've introduced so far. Dariush, over to you.
Thank you, Tom, and hi everyone. Thank you for joining us in this session. My name is Dariush, and I lead product management for JPMorgan's firm-wide AI/ML platform, OmniAI. And we are here today to tell you the story of OmniAI and how it can actually help smoothen the life of our data scientists at JPMorgan. So we're going to start with telling you a little bit about our business, a little bit about our business scale. We're going to touch on some of the high-level AI/ML use cases that we have tackled till date. Then we will jump into why the life of a data scientist at JPMorgan can be improved. It can be smoothened a little bit. We're going to talk about some of the challenges that data scientists they face. And then we're going to jump into OmniAI and talk about OmniAI. We're going to spend bulk of our time in these areas. We're going to have a demo of OmniAI as well, and then we will wrap it up with a few lessons that we learned along the way, and what would be our next steps. So, at JPMorgan, we are a full-service financial services institution. Just to give you a few data points to get a feel for our scale, Overall, we have about $27 trillion of assets under custody. We have 52 million active digital users, digital customers. We process about $6 trillion worth of payments daily on our platform. So that's the level of scale from our business perspective. So that translates into a very large technology organization. We have more than 50,000 technologists and software engineers in the firm, more than 6,000 applications, internal application and external applications. We process on a regular basis more than 450 petabytes of data. So that's the level of scale that our business works with. And at this level of scale, it is hard not to run the business by numbers and not to run the business based on scientific and quantitative approaches. So that translates into thousands of quant analysts, ML engineers, and data scientists at JPMorgan. Now, these ML engineers and data scientists, they tackle a variety of use cases. We have a relationship with more than 50% of households in the United States. 50% of households in the United States have some financial relationship with JP Morgan, which makes it very, very important for us to improve that customer experience. Every touch point that we have with customers, using data, using what we know about the customer, but without compromising the customer's privacy and without jeopardizing the sensitive data that the customer give us. So we put a lot of emphasis and a lot of efforts around using AI ML to improve customer experience for our customers, as well as our institutional investor clients and our other clients. Internally, we have quite a few FAQ bots and chat bots. So we need to train them using advanced NLP models, do a lot of searching into our content using Elasticsearch, and finding data from our knowledge bases. We play in every market that is out there, including equities market, stock market. So searching for patterns in those daily stock markets, finding better trading positions for ourselves and for our clients is another area that AI ML is heavily used in the firm. Quite a bit of active learning techniques to make sure that we are learning the most from the least amount of data that we expose our models to. And again, as you can imagine, we get quite a bit of emails in our organization from our institutional investors, private equity investors, other clients. So we do use quite a bit of AI ML to process those emails, manage those emails, queue them, send them to the correct place, classify them. And we have more use cases as well. So check out our technology blog where we put more and more information about the use cases that we tackle. Now, coming back to the life of a data scientist at JP Morgan, as I mentioned, it can be improved. It can be smoothened. There are some barriers to smooth data science at JP Morgan. I'm going to highlight a few on this slide. First and foremost is data access. Our data scientists have the exact same challenges with storing sensitive data, handling sensitive data, data sovereignty, like most of you in the enterprise world they have. But our data scientists also have to tackle an issue that we call it data use. In particular, before a data scientist can actually utilize a data set for a particular AI ML experiment, they need to make sure that that use is authorized for that data set. They need to go through a process to log that use and make sure that they have the adequate approvals for that intent of use. We are a large organization. We have a lot of legacy infrastructure. Like any other legacy infrastructure, it is built over time. It is patched over time. These are tightly integrated. So moving part or all of that infrastructure to public cloud, replacing rule-based engines with AI ML-based engines, all of that takes time and brings inertia to the innovation. Also, remember our scale. We have a very, very large scale from a financial and financial footprints perspective. And that level of scale itself will generate more inertia for smooth data science. We are a large org. We have many lines of businesses. These lines of businesses are regulated entities. They play in different regulatory environments. So as a result, making sure that those regulatory obligations are taken care of, again, slows down data science at times, unlike any other large organizations. And last but not least is our regulatory and compliance obligations. We take those obligations extremely seriously. I have briefly touched on data governance obligations, making sure that only the individuals who need access to a particular piece of data get access to that piece of data, making sure that they get access to that data for the correct intent to use that data. But that's not all. There are also model governance obligations that we have. So any model that is trained cannot go straight into a production environment. It needs to go through a model review and a model governance process to make sure we have another set of eyes that looks at how that model was created, how that model was developed. Did adequate experimentation done on those models? Is the model generating its intended results or not? Then we have software governance issues. Every model that is in production needs to be consumed by an application, different forms of applications. But these models are running in production. Software developers cannot access a production environment directly. So making sure that a model that is just trained and is running in a production environment can be accessed by software developers to develop an application on. All the SDLC and software governance issues comes into play. And then just to wrap this one up, issue of segregation of duties. A data scientist, an ML professional, is building and training a model in a lower development environment. They cannot just push the model up to a production environment. It needs to go through a model governance process. When the model is actually running in a production environment, they cannot access and debug that model in the production environment because of the level of sensitivity of data that is involved there. We do need an ML engineer, production engineer that maintains that environment. Same is true with data operations and data movement. About 2 years ago, we started on this journey to build a firm-wide AI ML platform and ecosystem for JPMorgan. We call it OmniAI. We partner with AWS and partner with the SageMaker team to build this end-to-end machine learning and AI platform on SageMaker and on AWS. Our platform exposes quite a few blueprints and patterns and reference architectures that one can use to do AI ML. We have different patterns for model training. We have different patterns for model inference and model hosting. We have patterns for data labeling. We have patterns for experimentation. Given that we only have 30 minutes, it's a little bit hard to fit all of those patterns here. But we selected one to walk through together. This pattern is about a data scientist doing interactive training using SageMaker via a Jupyter notebook. So let's jump into this. Highlighting a few areas here. First of all, you see that our platform deployment is actually a hybrid deployment. Part of our deployment runs in our data center, in our on-prem environment, in our private cloud. Parts of it runs on AWS and on public cloud. A data scientist first starts interacting with OmniAI Platform using our control plane that runs on-prem. That is where we look at data scientists' identity. We authenticate them, we authorize them using our on-prem ADFS directory. And then using that, then we know exactly which data sets this data scientist is entitled to, and we can correctly manage and set up that environment. We have quite a few risk governance, risk management, governance, and compliance controls as well that are applied at this stage. By the way, there is a different role, a data engineer role, that also uses our data pipeline, starting from on-prem to move data back and forth to our public cloud AWS-based environment. Now, coming to the AWS side, here we are depicting an account that is structured for training, for model creation, model optimization, and experimentation. And right next to that, it has three letters on it. It says HCD, highly confidential data, very sensitive data. So let's talk about that. In the middle, you see that we have an instance running. This instance is a Jupyter instance. So we have used our CI/CD pipeline to deploy a Jupyter notebook into this instance, secured by its VPC, right at the center of this blueprint. But you will also see that we have our S3 buckets in the corner. Now, S3 allows us to make sure that the data is encrypted at rest. And we rely on that service quite a bit. We utilize it to its fullest extent. We manage those keys ourselves. But for our very, very sensitive data, we add an additional layer of security and encryption on top of it. We have built a key management service at JPMorgan that runs within these accounts, backed by Cloud HSM, that again adds additional layers of encryption, key management, when a key is granted, when a grant is actually revoked, so that all of these moving parts together can make sure that the data is safe and secure as it is being processed on the Jupyter instance and on the SageMaker service. Of course, we generate quite a few logs and data points. So we use Kinesis, Firehose, and CloudWatch to capture all of those logs. We also have a log forwarder service that moves a portion of those logs to our private cloud logging service. So with that, let's actually jump into a demo and take a look at how this blueprint actually works in practice. In this demo, we are going to use OmniAI to train a very simple model using SageMaker. We are going to refer back to the architecture diagram that we just covered a few minutes ago and highlight where each piece of the puzzle actually fits in this architecture. A few things to look for in this demo. First of all, we are going to be using a data set from FDIC. In particular, FDIC summary of deposits for each bank for 2017 and 2018. It is a slightly enhanced data set because it also has a flag that says whether or not that bank failed sometime in 2019 and beyond. We have roughly about 178,000 rows in this data set. And our goal is to train a predictive model that can then look at the deposits coming into a bank and then gives us a probability of that bank failing 12 months or beyond in the future. So things to look for in this demo is how OmniAI environment creates a safe, compliant, but easy to use environment for the data scientists to do their machine learning and training, and how OmniAI SDK will then help the data scientist just to focus on the machine learning side of things and not worry about the infrastructure side of the puzzles. All right, so let's get started. As I mentioned, I am going to act as a data scientist in this demo, and I have already gone through the OmniAI system. I have already created a Jupyter instance. In fact, I am on that Jupyter instance right now. This Jupyter instance is a T3 X large instance running in US East. All right. Now, as a data scientist, I want to make sure that I am working in a safe, compliant environment. So I am relying on the platform provider to ensure that safety and compliance is in place. Therefore, as a platform provider, OmniAI needs to be quite opinionated as to how that environment is structured, how the different pieces of that environment talk to one another, but also what packages are installed in that environment. Couple of lines to actually highlight here. In these two lines that I've highlighted, the data scientist is basically saying, hey, OmniAI SDK, tell me which buckets I need to use, and also tell me what are the KMS keys that I need to use, without needing to actually worry about the long path to a bucket or what the KMS key would be. Again, going back to our architecture diagram, the way that we are setting up the bucket policies, the way that we are setting up the encryption, decryption keys for the sensitive data that goes into these buckets, these are all part of our blueprint and part of our pattern. We are relying on encryption at rest that comes with the S3 service by default. We rely on it quite a bit, but for our very, very sensitive data, we use JPMC's key management service to add an additional layer of security and encryption on top of what S3 provides built in. And this is where the OmniAI SDK allows the data scientist to just obtain those from the platform without needing to worry about it. All right, let's take a look at our data set. As I mentioned, this is a public data set, FDIC data set. It does have a column that identifies whether a bank has failed or has not failed, about 178,000 rows. In addition to fail and not fail, there are also 54 other columns that provide other data points for that bank, like such as the amount of assets that bank had, or the total number of deposits that were made into that bank, and the total amount of deposits that were made into that bank, as well as location of that bank. All of the metadata that is ultimately useful in creating a predictive model on it. All right, moving on. Again, talking about the OmniAI SDK. OmniAI SDK is built on top of SageMaker's Python SDK. What that means is that the data scientist can just import SageMaker, and then all the capabilities of SageMaker SDK in its raw form is available to the data scientist. Again, note that this environment is a safe, secure, and compliant environment, so the data scientist can just use the native SageMaker APIs to run their job. They need to make a few setups and modifications themselves if they wanted to, or they can use the OmniAI SDK and rely on the OmniAI SDK to take care of all of those setups for them. One function that makes it super easy for data scientists to not worry about any of that setup and configuration is this method: get PySDK training parameters. Let's actually take a look at this part of the code. Here, I, as a data scientist, I am just designing the parameters for the training job I am about to submit to SageMaker. I am telling it where is the entry point. In fact, here's the entry point. I am using SageMaker's built-in scikit-learn implementation, sklearn, and I am using one of the linear models. In particular, here I'm using logistic regression. So that's my entry point.
I want to run this training on an M5 large instance from SageMaker. I can choose any instance that I want. I'm starting with this one. Um, I am using scikit-learn, so I cannot use a distributed training. If I was using, let's say, TensorFlow, I could have created a cluster of 10 or 100 nodes or a large cluster. Here I am not. But the point is that I am actually using the built-in and native parameters that the SageMaker's API they take, and they create the job, the training job, and they run it. I, as a data scientist, only focus on those, and the OmniAI SDK will then get all of these parameters, will enrich them, will add other configurations to it, will then submit that job to the SageMaker service and runs the service. In fact, one of our acceptance criteria for our OmniAI SDK was that I, as a data scientist, should be able to go to any of the SageMaker tutorials, open source SageMaker tutorials, copy and paste that code into OmniAI, do very minor modifications like adding this line, click run, and the whole thing should run. We wanted to make it that easy and that straightforward. All right. Now, a few other things about how OmniAI SDK is helping the data scientists here. We have already talked about the KMS keys. We have already talked about some of the security aspects of this, like the security groups that gets set up automatically, or the roles that are configured automatically, but also items like subnets and how the VPCs and the networking and the communications between different components are covered. Last thing that you want to worry about as a data scientist is a subnet and VPCs and the networking things. You, as a data scientist, just want to focus on the mathematics and the ML side of the puzzle, and OmniAI SDK allows you to do that. So it looks like my training here has completed. Yes, it has, and I now have the model as a tarball created.
So as I mentioned, we have been on this journey for about a couple of years, and we have quite a few legacy workloads as well as brand new projects and brand new workloads on OmniAI. Just to share a few of the results that we have seen so far with you. Towards the end of 2019, we were able to, using the AI-driven technology, help JPMorgan Chase save about $150 million in expenses. So doing the same job, but at a lower cost. And in 2020, we were lucky enough to win CIO 100 award for innovation. Now, along the way, we took a few takeaways. We learned a few things. These worked for us. Hopefully, they will work for you as well. First, starting with what I tried to allude to a little bit earlier in the presentation, with the separation of duties, segregation of duties. In particular, something that we found very, very helpful was to embrace the separation of a data scientist, someone who trains and creates a model, and an ML engineer who then gets that model and then operationalize it. These two individuals, these two roles, are trying to solve the same end-to-end problem. But given that they are working in different environments, they are subject to different compliance and regulatory expectations. So looking at these two roles at different personas and building a smooth experience for each was something that we actually found quite useful and quite helpful. Which brings us to point number 2, around innovation. Building an end-to-end AI ML pipeline on top of SageMaker should be straightforward. Why? Because SageMaker takes you about 95-99% of the way there. That's not where the innovation can actually come from. Where we found where we can actually add quite a bit of innovation is around managing risk. And by managing risk, I don't mean managing the risk for the business, but managing the risk for the data scientist, managing the risk for the ML engineer. In particular, building code and building infrastructure that can remove that risk or lower that risk, or can create compensating controls around managing that risk. It may not be the sexiest type of software development, but it would be quite helpful in building a safe, secure, and fully compliant end-to-end ML platform. Which brings us to the third point. We are in financial services. It's a highly regulated industry. Many of you may be in other industries that they are highly regulated, like healthcare. At some point in time, you need to add your own customization. You need to add your own customization to make sure that the end-to-end platform fits your needs, fits your workflows, but also manages and lowers the risks that are unique to your environment. SageMaker and AWS will give you quite a few of those building blocks, but chances are they cannot take you all of the way there. So you need to create those customization. So it's better to just get over it, build those customization, and move on. So as you are building these customizations, you will see some pushback. Brings us to item number 4. You will see some pushback. You will see some inertia. You will hear sentences like, well, what I have in my on-prem environment is not broken. Why should I change it? Why should I fix something that is already working? It is at those times that we found being quantitative, measuring things, reporting on things, and showing the actual value numerically goes a long way. Numbers and data go a long way to change opinions and bring down barriers. Now, as you are thinking about those barriers, you may actually come across quite a few one-off use cases, corner cases. Always keep the 80-20 rule in mind. It worked for us. For the corner cases, don't focus on solving everything for that corner case. Add additional customization. Chances are the 80% of the workloads in the middle share quite a few things with one another. So you can actually solve that 80% set of use cases with one or two shots and one or two of those customization. And last thing that worked for us very well was embracing the ecosystem. And by ecosystem, we mean everybody can come to this platform and can contribute to that platform. They can not only contribute data sets and artifacts, they can not only contribute code, they can not only contribute blueprints and reference architectures, but they can actually come to our platform and build a new service on top of our building blocks and share it with the rest of the organization and with the rest of JPMorgan. We actually found that to be very, very helpful, not just because it makes our workload a little bit lower, but it actually helps build quite a bit of buy-in and quite a bit of interest in the platform. It worked for us. Hopefully, it will work for you as well. So in terms of the next steps, we of course plan to continue utilizing SageMaker and SageMaker Studio services. We have been lucky enough to collaborate with the SageMaker team on a few of the new services that they have built, some of which they have already announced during this reInvent. We will continue to do that. And along the way, we will continue to move more of the legacy workloads out of our legacy environment onto SageMaker. The new workloads are created on our platform anyway, but we will work very hard to move more and more of our legacy workloads onto SageMaker and OmniAI Platform as well. With that, I'll just wrap it up. Thank you so much for joining this session. Thank you, Tom, for helping put this session together. And of course, please do complete the session survey. We'd love to hear from you. Thank you so much.